So hey guys, welcome back to the channel. This is your physics buddy. If you are studying for your 2026 exam, you have come to the right place. Here you will find the detailed reviews of each and every topic you need to know, starting with electric charges and its property. We'll be covering the entire AP Physics 2 curriculum, so make sure to subscribe to the channel, like this video and follow along as I guide you through your preparation. In this video, we are going to discuss in detail all the aspects of electric charges and its properties.
Let's start our today's session.
Okay.
So in today's session, we are majorly going to talk about the charge and its properties and all the basic things that are associated with charge. We'll also talk about the fundamental behavior of charges. We'll talk about how charges are capable of attracting as well as repelling each other depending upon the nature. Before starting the unit, there are some questions that we might wonder that they are happening, but why they are happening, we're going to answer all these questions in today's session. So you must have seen this that if you just rub a balloon over your head and you try to attract the piece of papers placed on the table, you will see that the papers starts attracting towards the balloon. So why these are rising? That is one such question. We try to answer this question. Similarly, you must have seen that these kind of oil carrying tankers always have a chain which is hanging from the back of their ends. So why they have those chains and why they are always hanging from that tankers? Also, you always notice that these chains are always connected to the ground. Like when this oil tankers are moving, these chains will always suspended with the ground. So what is the reason behind it? We'll try to answer all these important questions. See, whatever we are learning here in physics, they have practical significance. So whatever you see around yourself, you can completely relate each and everything with the practical world. And always remember, in order to understand all these concepts well, just ask yourself this question, why? Why we are learning this? Because when we are questioning why we are learning this or why we are talking about this, most of the things get cleared at that time only. So that is the most important part about learning physics. And be curious, I would say. If you are curious enough to answer all these questions or ask all these questions, then it will be good. It will be easier to understand and study these topics. Otherwise, if you think of all these topics from the point of view of just textbook exams preparation, then they might not be that much interesting, which give you a little bit of you can say a good feeling, but that should not be the case. Always ask yourself why we are learning this. Always try to ask whatever you are seeing around yourself that why is it like that? If you are asking this question, all these things become a little easy to understand. So in today's session, we are going to talk about these particular topics, or you can say this particular unit has a lot of things that we need to. There are a lot of things that we need to understand, and this is going to be the topics that we need to understand in this unit, or you can say the first part of this unit. So just be aligned with the syllabus and try to learn as much as you can. The first thing we have to talk about that what is electric charge, what are its properties. Then we'll talk about what are the methods of charging. Then we'll talk about electroscope as well as Coulomb's law. I gave a little bit of idea about all these topics in the first session, but today we'll go, or you can say we'll deep a little more down into these topics and try to understand it from the basics. So, first of all, let us try to understand what electrostatic is. So, electro means charge. Like whatever charge we have, it can be represented by the word electro, whereas static means at rest. So, electrostatics is a unit of physics which deals with study of charges at rest. So, whenever we are studying all the effects of charges when they are at rest, that whole thing comes under this unit called electrostatics. Always remember, charges, as I informed you, They can be present in multiple states. Either they can be at rest, either they can be in motion, or you can say uniform motion, or either they can be moving with some accelerated motion, like their speed is increasing continuously. So in all those scenarios, the effect this shows in our surrounding is completely different. So we'll try to understand how they show their effect and we'll deal each and everything. We'll deal with each and everything in this particular unit. So always remember, as I told you, charge is an intrinsic property of any kind of matter. Any kind of matter means whatever we have around ourselves, solid, liquid, gas, every matter, every type of matter possesses charge. And that charge can be positive, that charge can be negative. We'll talk about it. Let's move ahead. So what is the significance of understanding or learning electrostatics? So, in order to explain the significance of it, let us just try to figure it out that where do we actually observe charge and what are the situations which actually affect charges or the study of charges. Let me give you a very simple example. We always observe during rainy season that there is a thunderstorm going on. So, how the thunderstorms occur in nature? That will help us to understand through electrostatics only. Similarly, during rainy season only, we observe that whenever we try to touch any untouched metallic surface which is undisturbed from a longer period of time, when we just try to touch it, we feel a little bit of like spark or we just feel a little bit of current through it. So we need to understand here is that understanding the behavior of conductors will ultimately help us to understand that how the motion or you can say how charges actually behave. So whatever we are going to learn, we need to understand it from the point of view of its actual behavior that we observe in our surroundings, in our natural world. So there are many questions that we are going to answer in this particular unit. Similarly, always we are advised that whenever there is lightning going on, and if you are inside a car, just stay inside a car or always try to cover yourself with some sort of shelter. Why is it like that? So, suppose there is a lightning going on and that lightning just hit the car like that. So, what happens here is when this enormous charge falls on the surface of the car, whoever is sitting inside it will not get affected through this charge. Why? Because all the charge will flow through the body of the car into the ground. And this process is generally called earthing. So how earthing protect what whoever is sitting inside the car? It protect us in such a way that whoever is sitting inside the car will not suffer from any of these external lightning. Why? Because charge has a very important property. The charges always lies on the surface of the conductor. Whatever surface we are observing, whatever conductor we are talking about, that conductor must have some surface. So whatever charge it possesses, that charge always lies on the surface of it. There is no charge inside the conductor. That is the most important part about conductors. Whereas any other type of matter can do have charge inside it, but conductors always possess charge on the surface. So when the lightning strikes, all the surface get charged, and that charge will always move to the ground or the earth through the tires, you can say, and that is the reason tires are a little bit of conducting in nature. Although all the rubber material which we use to make tires, they are not conducting generally. But the tires of all the automobiles are made in such a way that they do have the property of conducting a little bit of charge. So that is a very important part. Similarly, if someone asks you which tires are more conducting, a tire of, or you can say a four-wheeler vehicle or an aeroplane. So the aeroplane tires are more conducting in nature. Generally, we observe that all the tires we use in all the automobiles, they have air in it, or we just try to fill it with air. Whereas if we talk about the airplane's tire, that airplane's tire are completely made of, you can say, rubber or elastic particles, elastic material. Because once the plane is in air, passing through all those clouds, enormous amount of charge just stick to the surface of the conductor surface of the airplane. But what happens when that airplane lands on the ground? All the charge passing through those tires just went into the ground, called again earthing, and that earthing prevents any harm to the body as well as whoever is inside the plane. So there is a lot of things that we need to understand here that electrostatic unit is something which is responsible for so many factors. The first time when plane was made by those two brothers, they don't take it to the very great height, you can say. But when we discussed, when we just try to understand all the necessary factors that can affect the plane, this was the major factor. This electric charge that all residing between the clouds is the major factor that we have to do so many changes onto the plane's model, we can say design. We'll talk about those things as well. Let's move ahead. So next thing we need to understand that what is static electricity. So electric charge is basically, you can say it is a basic property of all the matter carried out by some elementary particles that govern how the particles are affected by electric or magnetic field. This is an important scenario. So as of now, just keep this thing in mind, although we'll learn these two fields in detail in the upcoming classes. So electric field and magnetic field, these are the two kind of fields that are there and that are existing because of the charges only. But what we observe here is that these electric and magnetic field do affect the motion of charge. It do affect the behavior of charge when they are kept inside it. So suppose there are two charged particles. One charged particle is kept inside a magnetic field and one charged particle is kept inside a electric field. Remember, electric field is represented by E vector, whereas magnetic field is represented by B vector. Okay, just tell me one more thing. Do you have any idea about uh, vector quantities like scalars and vectors? Like, what is the difference between scalars and vectors?
Yeah.
So, tell me a few things about it.
Uh, Vector is a quantity with a direction stated with it, and scalar is a value with no direction given.
Okay. Anything else apart from this?
No.
See, this is the very basic or elementary definition that we know about scalars and vectors. But the most important part, me, or you can say the most important difference between scalars and vectors is how they can be solved. Scalars uses basic fundamental mathematical operations which we have learned so far, like addition, subtraction, multiplication, division. But vectors do not follow these. For addition and subtraction, we have different laws that we follow to solve vectors. Similarly, when we talk about the product or when we talk about the multiplication part, vectors follow special operations like dot product, cross product. I'll try to explain you once we need to understand these things in particular concepts. So these concepts will be there in the upcoming units. So just make sure you keep yourself aligned with it. So electric charge is a basic property of matter. Whenever we're talking about those electric charge, so these electric charge are affected by in which field they are kept, electric field or magnetic field or whatever it is. So we'll understand the behavior of these charges in both electric and magnetic field once we understand the electric charge completely. In today's session, we try to understand what is the electric charge and how they are going to affect surroundings. So electric charges are basically of two types. The first we can say positive charge, and other we can say negative charge. Apart from this, there is no other type of electric charge. Always keep this in mind. When we talk about positive electric charge, so positive charge is always given by proton. So proton is a part of nucleus. It always inside an atom, and it gives the positive charge to the atom, and ultimately it gives the positive charge to the body which it has. Similarly, negative charge is always represented by electron. Again, it stays inside the atom but outside the nucleus, and it is responsible for giving a negative charge to the body. So, suppose if some body absorbs, or you can say just got some protons from outside, so that body will become positively charged. Similarly, if body gains some electrons from outside, it becomes negatively charged. When we are talking about protons, we generally represent it by E positive. When we are talking about electron, we generally represent it with E negative. The charge of proton and charge of electron, they both are same, but the difference is their sign. When we are talking about the charge of proton, so we can say that E plus is nothing but 1.6 into 10 to the power minus 19 coulombs. Coulombs is the unit of charge. Just keep this in mind. Similarly, when we are talking about the charge of electron, we always write negative of 1.6 times 10 to the power minus 19 coulomb. So that is the only difference. Proton is positively charged, whereas electron is negatively charged. We can also talk about the mass of proton as well as the mass of electron. So mass of proton is equals to 1.67 times 10 to the power minus 24 kg. Whereas if I talk about the charge of, or you can say the mass of electron, the mass of electron is always equals to 9.1 times 10 to the power minus 31 kg. Now, these are the very important information, and in most of the questions we are going to use it. Sometimes this information is there in the question, which will help us to solve the numerical, obviously, but sometimes it is not there. So we have to remember these three things: charge and masses of each proton as well as electron. We are going to use it for sure in so many questions. Just keep this point in mind. Also, there's one thing that we need to understand: same charge will always repel each other. If it is positive, positive, they are going to repel. But if we're talking about the opposite charges, like positive and negative, they are going to attract each other. So that is the two significant behavior that we talk about the charges. Like for example, so how do they actually repel or attract each other? They repel or attract each other by applying force. So this positive and positive will try to repel each other. So this they will apply force in the opposite direction so that they will move apart. Similarly, if there is negative charge, again they will try to repel each other by applying force in the opposite direction. Similarly, if there is positive and negative charge, they will try to attract each other, so the force will act in this direction. So this shows the repulsion between the same nature of charges, whereas this shows the attraction between opposite nature of charges. We'll talk about these things in a little detail, or how much force they actually exert when they are attracting or repelling each other. We'll talk about each and everything in detail in some time. Now let us try to understand what are charge carriers. So first of all, let us define that what charge carriers are. Every type of matter which we are observing around ourselves, if they are able to conduct, they must have some charge carriers present in it, which is responsible for the conduction of current or any other type of conduction that is going through it. Like for example, if we're talking about conductors, so conductors have free electrons, and these free electrons are responsible for the conduction of current through it. Now, what are these free electrons? These free electrons are those electrons which, if they get sufficient energy in the form of anything around themselves, like in the form of thermal energy, in the form of frictional energy, and something like that, they will be able to move. Or if they face any, if they feel any kind of force on them, they will move. And because of their motion, we observe current in those conductors. So, charge carriers are you can say those quantities which are actually responsible for conduction. These are those quantities which are actually responsible for conduction in any type of matter we're talking about. So the first matter we talked about is conductors. So conductors has charge carriers as free electrons. Then we talked about electrochemical cell. Electrochemical cell is the general cell which we use in everyday life. Like for example, a cell which runs the remote of any appliance, a cell which runs toys. So all these cells are generally called electrochemical cell, and these electrochemical cells has ions in it. Ions in its solution. Do you know how electrochemical cell actually works?
No.
So we'll be talking about the cell in current chapter. When we are dealing with current, when we are dealing with how cells actually work, we'll talk about how ions in solution are responsible for the conduction of current. So everything is in the syllabus. We'll talk about each and everything in detail. Then there is another such type of conductor material which is called semiconductors, and semiconductors has electrons as well as holes which are responsible for conduction. Now again, this is completely new thing, like what is holes, how electrons and holes simultaneously responsible for the charge conduction in the semiconductor, and how semiconductors are actually used to convert solar energy into electricity. That is another such, or you can say a very important or revolutionary discovery when we just got to know about semiconductors. So we'll talk about them as well. But as of now, you just need to keep in mind conductors have free electrons, cells has ions, semiconductors has electrons as well as holes. Similarly, when we talk about nuclear reactions, so nuclear reactions, the charge carriers are neutrino and antineutrino. These are again a different kind of charged particles or the charge carriers which are there in those type of reactions. Only these four type of, or you can say, conductors or charge carriers are present in the entire universe as of now, as of our studies. But in future, we might be able to discover some more type of charge carriers. But these are charge carriers which we found on Earth as of now. So that is why we need to understand about these charge carriers. Let's move ahead. A very basic, simple question here I have for you. Just try to answer it and let me know what you just infer from this. So the question says the charge carriers in a metal are electrons rather than protons. This is due to the fact that electrons are. Now just try to tell me why protons are not the charge carriers, why electrons are the charge carriers in a conductor. What do you think? What should be the basic reason behind it? Why we are saying that electrons is the charge carriers, not the proton? What is the reason? What should be the reason? Think about it.
Uh, should it be all of the above?
Yeah, it should be all of the above. So, if you talk about an atom has a nucleus, and we all know this nucleus is nothing but it is positively charged. And this positive behavior or positively charged nucleus is due to the presence of protons in it. But apart from protons, there is also present one more thing which is called neutrons. Those neutrons are electrically neutral charged particles, or we actually don't call them charged particles. These are the neutral particles which only contribute towards the mass of the nucleus, not towards the charge of it. So all the positive behavior of nucleus is due to the protons present inside it. But protons are not exactly transfer or move from one atom to another atom when it comes to conduction. So these electrons which are present outside the nucleus are actually responsible for the conduction that is going on in between the two metal surfaces, I would say. So the electrons are considered as the charge carriers because first of all they are loosely bound. If they get sufficient energy, they will excite. If they get sufficient energy, they will excite and move out of it. Also, we have already seen that the mass of proton in comparison to mass of electron is very huge. Like you can see if you just compare the powers of their masses, the mass of electron is 10 to the power minus 7 times less than the mass of the proton. So if the mass of electron is 10 to the power 7 times less than the mass of the electron, obviously they are light. So that is another reason they are lighter. And also in comparison to the distance, protons are very far from the nucleus. So if they are very far from the nucleus, so that is the reason why they are considered as the charge carriers. The answer is correct. Now let us talk about what are the different unit of charges we have with ourselves and how we are actually going to deal with these units. So as I told you that basically we are going to measure charge in coulombs. Charges are generally measured in coulombs, and that coulombs is nothing but the SI unit. Like what is SI unit? What is the difference between SI unit and other different units of charges? The major difference between SI unit and CGS unit is that SI unit is the unit which we use to solve, which we use in all the numericals we are going to use or all the problems we are going to use. But all the other units we might see of charges, these units are used in some specific questions only. Like not in all the questions we are going to use, but in some different, or you can say some situational questions which exactly requires the use of those units, we're going to use them. Similarly, if we talk about CGS unit, so CGS unit is something which stands for it is a different system which follows different fundamental physical quantities. Like for example, let me just tell you. So as of now, we have 7 fundamental physical quantities that is being used to represent all the units. Like for example, for length, we use meters. For time, we use seconds. For mass, we use kg. For temperature, we use Kelvin. For intensity, or I would say luminous intensity, we use for luminous intensity, we use candela. For amount of substance means when we are actually talking about atoms and molecules. So we measure them in moles. Then if we talk about current, it is measured in amperes. So all these units are fundamental units. And from these fundamental units only, we derive all the other units. Like for example, this charge, is not a fundamental unit, or this Coulomb is derived from these fundamental units only. Like for example, charge is basically given by the product of current and time. So that current has a unit I, current has a unit amperes, whereas time has a unit seconds. So this charge has a unit of ampere second, or this ampere second is also known as coulombs. Why coulombs? Because coulombs was the first person who identified the charge, who identified the mathematical aspect of charge. So in order to represent his, you can say, discovery, he just tell the whole world that ampere second is also regarded as coulombs, and we also accepted it because this is something which resembles his efforts, his work, which made us understand that how charge or any other thing works. Similarly, if we talk about the CGS unit, the CGS unit of charge is called stat coulomb. Now, again, that thing should come to your mind like what is CGS unit? So, CGS unit is another aspect of representing charge, whereas all these quantities, all these fundamental units are different. So, initially, what happened is when the whole world is not united or not recognized by the work of one country or the another country. So, what they used to do is they used to just give different names for the different things they have in their country. Like, for example, suppose if you talk about the two continents, let's say Asia and Africa. So Asia must be measuring length of any material, like let's say in meters, whereas Africa must be measuring the same thing in centimeters. Although both the units are completely fine with respect to the countries. But when we united the whole world, when the trade begins in the late 18th, or you can say not late 18th, late 16th or early 17th century, when the trade begins between the countries, we have to come across this particular one thing that units should be unified. Like the measurement of the two different quantities should be unified so that each and every country can trade easily. So then we came across this particular system called SI units. So that is the reason why whenever we are talking about any numerical, we'll be using SI units. But in different scenarios, we might be using different units of all the physical quantities which we have learned so far. Similarly, if we talk about the largest unit of charge, it can be depend upon the question, or we might be using the largest unit of charge as mega coulombs, which is represented by capital MC. Although this is a very huge measurement, 1 mega coulomb is approximately 10 to the power 6 coulombs. This is a huge number, not a small number. Similarly, there are some other physical units we might use for the charges. It can be microcoulombs, nanocoulombs. It can be sometimes E also, like the charge of electron can also be used as a unit. So there are so many units. When we are talking about any specific question, if there is that other unit, other from, I would say, coulombs, we'll talk about that particular unit also in that case. Similarly, there is one thing called dimensional formula. So as of now, as you haven't talked about the dimensions yet, so let us skip this particular part. All that will take a lot of time to understand. Or if, or if there is any need to understand this, we'll talk about it. So let's move ahead as of now.
Okay.
Although it's there, the dimensional formula of charge, it's M0 L0 T1 I1. We'll not talk about how this thing came. You can just keep in mind if it is there, just mark the answer as this. Now the thing is, how can we actually measure charge? How charge can be measured? So charge can be measured in such a way that, for example, suppose this is a conductor and a small current is flowing through this conductor like that. So the charges is defined in such a way that whatever current is flowing through that conductor in a given time will give us the total charge. Or this definition of charge is basically given by the definition of current. So earlier on, when scientists understand about the current, they simply said that current is nothing but the flow of charge, or you can say the rate of flow of charge. It means whatever amount of charge is flowing in a unit time will give us the current. So from here we find out that the product of current and time will ultimately give us charge. So this relation which we are going to use in the in some numericals are basically came from the, you can say, definition of current. So this current definition ultimately gives us the relation for calculating charge. So we'll be using this relation in some of these questions which we might see. Now that is the one such question. How many electrons are required to make one Faraday? Now, you might be wondering that what this Faraday is, but again, this is another person, another scientist, and he is also responsible for so many discoveries in the physics as well as in the science. So first of all, let us try to define that what is Faraday. So a Faraday is a unit of electric charge, and one Faraday is basically defined as the amount of electric charge that is carried out by 1 mole of electron. Let us try to write it first. It is a unit of electric charge, 1 Faraday, which is represented by 1 capital F. It is defined as the amount of electric charge carried by 1 mole of electrons. Do you have any idea about that? What is mole?
It is the number of molecules in a system.
Mhm. Not exactly, but somewhat it is correct. So basically, mole is the unit to measure the amount of substance in microscopic level, or you can say the amount of substance that is there in given some amount of substance we have. Like whatever number of moles we have in 10 ml of water. So that mole is basically representing that how many molecules do we have. Or you can say moles is generally representing how many atoms that particular compound may possess. So it is a unit which actually measures the amount of given chemical substance, but at subatomic level, or you can say at atomic level. So at atomic level, when we're talking about any of these physical quantities of any of the matter we have and we try to measure it, so we try to measure it in moles. So the question is, what is 1 Faraday and how it can be actually used to represent the charge of, you can say how many electrons are there in 1 Faraday? That is the question. So just keep this point in mind that the 1 mole of whatever amount of electrons are present in 1 mole of a substance is basically the charge that possessed by 1 Faraday. So here we can find that the total number of electrons that possessed by 1 mole of substance is basically the total charge it possesses. So here we will answer it in this way that in 1 Faraday, total of Na. Na is also known as Avogadro number. You must know about it. Also called Avogadro constant. So in Faraday, a total of Avogadro constant. कितना होता है? Do you have any idea that how much this Avogadro constant is?
I think it's 1.38.
No. So in 1 Faraday, a total of Na, that is 6 into 6.022 into 10 to the power 23. Total number of electrons are there. Na number of electrons are there. So the question is might not limited to that how many electrons are there, but it can also say that how much charge 1 Faraday is equivalent to. So when we have to calculate the charge of 1 Faraday, we'll simply say that 1 Faraday is equals to Na times charge of electron, which is equals to 6.022 into 10 to the power 23 times what is the charge of electron we just saw in the previous slides. It is 1.6 times 10 to the power minus 20 minus 19. So when we solve this, we ultimately got that 1 Faraday is equivalent to 96485 coulombs. So it's a huge number and it might be there in any of the MCQs. It is being passed in the class or in any other thing. So we have to keep these things in mind. Although I will suggest that whatever is going on in the class, just make sure that you share it with me as it is. Like whatever notes you are preparing, just share it with me as it is. This is
Okay.
the huge unit. All the topics we are going to learn here, they have a lot of, you can say, deviations. I just wanted to keep it aligned with the syllabus so that we don't deviate from our goal. Otherwise, there are endless topics. We can discuss them like till the whole year. Even this particular unit can be discussed for the whole year. But we just want to stick to the syllabus and we just want to stick to the required part. We won't move ahead. Now, this is one such question. How find the total positive charge on 36 grams of water? Although these kind of questions will definitely be there in your exams. So just think and tell me how we are supposed to answer this, how we are supposed to find this. Any idea? Think about it. Tell me.
A number of electrons present in the water.
Yeah, so basically we'll try to first of all figure it out that how many protons are there in 36 grams of water. Because positive charge is basically a result of protons, right? So we have to figure it out that how many protons are there in 36 gram of water. Let us try to figure it out. In order to answer it, you need to understand this particular fact that 1 mole of any compound consists of Avogadro number of atoms. Again, this is the very important thing you need to remember. One mole of any compound consists of Avogadro number of atoms or number of molecules. So let us try to figure it out that how many moles are there in 36 gram of water. Do you know how to find how many moles are there in 36 gram of water? You might have learned it in chemistry. So water
Uh,
is basically represented by H2O. Don't worry, just try to understand. Water is represented by H2O, we already know it. Let us try to find out the molecular mass of water. The molecular mass of water is given by like twice of H, that is 1 plus what is O? O's molecular mass is 16. That is going to be 2 plus 16, that is 18. So overall molecular mass of water is supposed to be 18 grams per mole. That is the unit of it. If we try to find out the number of moles in the given amount of substance we have, so that number of moles is represented by given mass, whatever mass we have given of the given substance, over its molecular mass. So as you can see that the molecular mass is somewhat 18 and the given mass is somewhat 36. So the total number of moles this 36 gram of water possess is going to be 2. So there are two number of moles. We understand this fact that one mole has this much number of atom. Again, one mole has Avogadro number of atoms. That is 6.022 into 10 to the power 23 atoms are there. One more thing, if we talk about, uh, we can say atoms as well as molecule. If it is atom, like if we are talking about an atom, we'll write atom as this water is a molecule. So here we can also write that one mole of given substance is equals to this much number of molecules. It is there in this much number of molecules. So here you can say that 2 moles of water must possess twice of this number of molecules. It might possess twice of this number of molecules. So this number of molecules will give us around 12.044 times 10 to the power 23 number of molecules are there. Now we have to figure it out that how many protons are there in one molecule of water. Again, this is an important question. It will be there in your weekly or upcoming test when you're talking about this particular unit. So here, one molecule of H2O will possess how many protons? That is the question. So one molecule of H2O will possess around 10 protons. How we can say that? Hydrogen has one proton in its atom, so twice into one. Whereas oxygen has 8 protons in its nucleus. So the total number of protons it will possess is around 10. So there are 10 protons. Now, one molecule has 10 protons. 2 moles has this much number of molecules. So how many protons are there in 36 gram of water? We just figured it out. The 36 gram of water might have 12.044 times 10 to the power 23 times 10 protons. Does all these things make sense?
yeah,
So 36 gram of H2O will have 12.044 times 10 to the power 24 protons. Now, the question is how find the total charge, total positive charge. So what is the charge of one proton? 1.6 times 10 to the power negative 19 coulombs. How many protons do we have? We have this much number of protons. So we'll simply multiply these two quantities and we'll get the total charge, total positive charge possessed by 36 gram of water. So you can see that 36 grams of water possess a huge charge. It's not a small amount of charge, small amount of positive charge. Whatever amount of positive charge it possesses, similarly the same amount of negative charge also it possesses. So it's a pretty interesting thing if you just think of it this way. So the total charge we can say is going to be 12.044 times 24 times 1.6 times 10 to the power minus 19. Can you solve it and tell me what should be the total charge? Try solving it and tell me what should be the total charge. Just multiply the numbers.
Okay. Uh, 35.27.4 times 10 to the
How
fifth power.
35? You just have to multiply 12.044 into 1.6. It won't be 35. It should be 1.9264 times 10 to the power, I would say 5 or 6. So it's a huge number. It's not a small number. But you need to understand that how all these things came. You need to understand each and everything we have learned. And these are pretty important things. You need to understand them from the basics.
Okay.
So whatever we have learned so far in today's class, all these things make sense.
Yeah. Most of them. Yeah.
Just make sure that you revise each and everything and try to understand what is there.
Okay.
If you just try to understand each and everything to a little good extent, it will be good. Although, let me just give you the overview that what we have to do in the upcoming classes, or we'll talk about the charge and proton. This is your homework. You can just figure it out. Just try to do some research and get about it. What is the charge of proton? I already told you. What is the mass of proton and electron? I already told you. Now there are four different charge particles: positron, neutron, deuteron, alpha particle. That is what you have to figure it out. Similarly, you can also do that question in homework. What is the charge of alpha particle? Whatever you're going to find out in this particular page, you can just substitute it here and tell the answer. Again, there are some questions. I'll share some of these questions. You just try to answer them and we'll discuss the same in the upcoming class.